This video is about numbers in Python and operations with them, and about typecasting. The main numeric data types in Python are integers, integer data type or int class, and fractional real numbers, also called floating points numbers, float data type or float class. There are others, but these are the main ones. We can perform various arithmetic and other mathematical operations with numbers due to corresponding methods of these data types. Let's use the dir function again and pass into it the 1. And we can see all attributes of the int class. This underscore underscore add underscore underscore is a method that is responsible for addition operation and so on. For numbers, we don't explicitly call these methods, and we do all math operations in the way we are used to, like on a calculator. And so on. Multiplication, power, and others. The priority of math operations is the same as in math. Well, it couldn't be otherwise. Operations with brackets we use the same way also. 2 plus 2 multiplied by 2 equals to 6. Parenthesis multiplied by 2 will be 8. 10 divided by 3 will get a fractional value. If I pass the result in the type function, we will see that this number is an instance of the float class. Float numbers is a computer science concept of the real numbers in math. To round fractional numbers, floats for example, we can use the round function. Rounding rules are also standard. By default, the round function rounds its argument to nearest integer. If, for example, we need to round the number to 4th decimal place or to the seconds, then we need to pass the second argument into the round function. Round 10 divided by 3 as the first argument, then comma, and then the second argument. Decimal places. There is also such a division operation using the percent character. This is modulo. And this operation returns the remainder of the division. 3 divided by 2, 8 modulo 3 will return 2. Sometimes you will need it. For example, the criterion for the evenness or oddness of a number is its divisibility by 2 completely. That is, the division remainder will be 0. Sometimes it is necessary to check the evenness of a number, and there is a real-life example for you. For example, the jurisdiction of some civil courts in Moscow in Russia is based on oddness and evenness of the numbers of houses on the street. If houses on the street have an even numbers, then these houses are under jurisdiction of one court, otherwise they are under jurisdiction of another court. Also, there is another division operation with 2 slashes. It's an integer division. It will return an integer part of the division and the remainder is discarded. For example, 10 divided by 3 will 3, or 27 divided by 5 will 5. And the next topic is typecasting. Typecasting is the conversion of one data type to another. Not all data types can be converted to one another, but data that are similar in meaning can. For example, the 1 as a string can be converted to float, or can be converted to integer type for further calculations. As you remember, I said that one as an integer and one as a string are different data types and they behave differently, and we cannot add strings to integers. Number plus string, we cannot do it because what should be the result in this case, a number or a string? Python refuses to do it. And therefore, in order to do something like this, it is necessary that all the data participating in this operation belong to the same type. 1 plus 1, or 1 as a string plus 1 as a string. You can tell what is the strange notation, numbers like strings. Where do they come from? In fact, we can get them from different sources. For example, a fairly common situation is the data that we input into HTML forms on websites. All data that we input in HTML forms are strings. For example, a bank transfers a certain amount of money from bank's web application. And so the amount that you input into the form on the site is a string. And to calculate the transfer fee, for example, this amount should be converted to a numeric data type. How to convert types? Formally speaking, we pass an object of one type or class into the constructor function of the another class we want to convert in. And as the result, we get an object of this desired class. In practice, it means that we just call the int function to get the integer and pass into it a string object as an argument. And such a string object as an argument should only consist of numbers. The same can be done with the numbers to convert a number to a string class. Str function that gets 1 to 3 as an argument will return 1 to 3 as a string. Casting a fractional number, a float for example, to an integer will cause the fractional part to be discarded. Int 27 will return 2. Sometimes it is very convenient. To convert integers to strings, use the str function. To convert to the float type, use the float function. If Python fails to convert an object of one type to an object of another type, it will raise an exception. Invalid literal for int with base 10. Essentially, this exception says that the wrong literal was passed into the int function to convert to an integer data type, and after the colon, it puts the argument that was passed into the int function, my argument. Therefore, in order to avoid such problems, when incorrect strings get into functions like ints or float and others, string class have several methods that allow us to check whether a string object contains only numbers or only letters. And string class has isdigit and isalpha methods. For example, let's suppose I have a string and I want to check whether this object has only digits or not, and I'm calling the isdigit method. And it returns true, which is in essence means yes, or it can also return false. In essence, it means no. More about it a bit later. And in a similar way, if I call the isdigit method of a string object that contains not only numbers, but also other characters, then the answer, the returning value, will be false. For example, 1, 2, 3 and a isdigit false. How to use such checks before typecasting we will look at a bit later, but for now I'll just point out that such methods exist and they can be very useful. This concludes our preliminary video about numbers. We will return to them a bit later again. In the next video we will talk about variables, overriding variables and dynamic typing. If you like the video, please leave a like and subscribe to the channel. Thanks for watching.